Trigonometry, an introduction to sine, cosine, tangent, and exercise. Trigonometry, exercise 1. This is an exercise on basic trigonometry questions. Pause the tape at this point and have a go at these questions yourself. When you're done, restart the tape and I'll go through the answers. Okay, let's have a look at how we can solve question 1. In each part we're given a right angle triangle. One of the other angles is given along with one of the sides. You're asked to find the length of a missing side x. So in part A, we're given a triangle. The angle is 36 degrees and the important thing to do is to name the sides. So the side 12.5 is opposite the right angle and so it's called the hypotenuse. The angle x is opposite to 36 degrees and so it's called the opposite side. Now we have sine of an angle is opposite over hypotenuse. So we have the sine of 36 degrees is x over 12.5. Now if we multiply both sides by 12.5, we get 12.5 times sine 36 equals x, and we can just type this into the calculator. We just type in 12.5 times sine brackets 36 close brackets equals, and the calculator will display 7.347315. Now if we round that off to one decimal place, that gives us an answer. The length x is 7.3 centimetres. Now in question B, we're given a triangle with an angle of 47 degrees. The first thing to do is name the marked sides. Now the side x is directly across the triangle from the angle 47 and so it's the opposite side. The side 6.7 centimetres is next to the angle 47 degrees, so it's called the adjacent side. Now we have the tangent of an angle is the opposite over the adjacent. So the tangent of 47 is x over 6.7. Now if we multiply both sides of the equation by 6.7, we have 6.7 times tan 47 equals x. And if we type that into the calculator, 6.7 times tangent of 47 equals, we get the solution x is equal to 7.184870. Now if we're going to round that to one decimal place, our answer is x equals 7.2. In part C, we have a triangle with an angle of 27 degrees. Again, name the sides. Now the side 13.9 centimetres is the side that's opposite the right angle, so it's called the hypotenuse. The side x is next to the angle 27 degrees, so that one's the adjacent side. Now we have the cosine of an angle is the adjacent over the hypotenuse. So the cosine of 27 is equal to x over 13.9. If we multiply both sides by 13.9, we get 13.9 times cosine of 27 equals x. And if we type that into a calculator, we get x is equal to 12.38499. So our answer is, rounded to one decimal place, x equals 12.4. In part D, we have a triangle with an angle of 73 degrees. Again, the first thing to do is name the sides. Now, the side 8.9 centimetres is opposite the angle 73 degrees, so it's the opposite side. The side x is next to the angle 73 degrees, and so it's the adjacent side. So we have opposite and adjacent, and we know the tangent of an angle is opposite over adjacent. So tangent of 73 is 8.9 over x. Now if we multiply both sides by x, we get x times tan 73 equals 8.9. Now to get x on its own, we need to divide both sides by tangent of 73. So x is equal to 8.9 divided by tangent of 73 degrees. Now if we type that into a calculator, we get x is equal to 2.721 and more terms. Rounding that off to one decimal place, x is equal to 2.7 centimetres. Now in part E we have a triangle with an angle of 24 degrees. Again, name the sides. Well, the side which is 3.6 centimetres is directly across from 24 degrees, so that is the opposite side. The side x is the longest side of the triangle opposite the right angle, and so it's the hypotenuse. Now we have opposite and hypotenuse, and we know the sine of the angle is the opposite over the hypotenuse. So that tells us sine of 24 degrees is equal to 3.6 over x. We can multiply both sides by x, and that gives x times sine of 24 degrees equals 3.6. If we divide both sides by the sine of 24, that gives x equals 3.6 divided by sine of 24. And if we type that into the calculator, we get x is equal to 8.850936. Now that gives us an answer to one decimal place of x equals 8.9 centimetres. In part F we're given a triangle with an angle of 71 degrees. As always, the first thing to do is name the sides. The side x is directly opposite the right angle, which means that it's the hypotenuse. The length 8.3 centimetres is next to the angle 71 degrees, so it's adjacent. So we've got the adjacent and the hypotenuse, and we know that's the cosine. The cosine of the angle is equal to the adjacent over the hypotenuse. So the cosine of 71 degrees is equal to 8.3 over x. If we multiply both sides by x, we get x times cosine of 71 equals 8.3, which means x is equal to 8.3 over cosine of 71. So x is equal to 25.4938. Rounding that off to one decimal place, our answer is x is equal to 25.5 centimetres. Now in question 2, we're again given several triangles. This time we're given two sides and we're asked to work out the missing angle. So in part A, the first thing to do is name the sides. The side 12.5 centimetres is the longest side. It's opposite the right angle, so it's the hypotenuse. The 9.8 centimetres is next to the angle theta and also next to the right angle, so it's the adjacent side. Now we know the cosine of an angle is the adjacent over the hypotenuse. So cosine of theta is equal to 9.8 over 12.5. Now, if we know the cosine of theta is equal to something, then theta is the inverse cosine. On the calculator, that's shift cosine. So we have theta equals shift cosine, in brackets, 9.8 divided by 12.5. So theta is equal to 38.3717 degrees. Rounding it off to one decimal place, theta is equal to 38.4 degrees. In question B, we have to do the same thing, name the sides. The side 4.1 centimetres is next to the angle and next to the right angle, so that is the adjacent side. The side 6.3 centimetres is opposite the angle theta, and so it's the opposite side. So we have adjacent and opposite. Now that's the tangent. We know the tangent of an angle is the opposite over the adjacent. So the tangent of the angle is 6.3 divided by 4.1. And to work that out, we take the tangent to the other side by making it the inverse tangent, or on the calculator, shift tan. So theta equals the inverse tangent in brackets of 6.3 over 4.1. And that gives us the answer, theta equals 56.94417. Rounding that off to one decimal place, we get our answer, theta equals 56.9 degrees. In part C, again, we name the sides. Now the side 12.1 centimetres is next to the angle theta, so that's the adjacent. The side 14.6 centimetres is the longest side opposite the right angle, so it's the hypotenuse. So we've got adjacent and hypotenuse. And we know the cosine of an angle is adjacent over hypotenuse. So the cosine of theta equals 12.1 over 14.6. So theta equals the inverse cosine of 12.1 over 14.6. And that gives us theta equals 34.0277 degrees. So our answer, rounded off to one decimal place, is theta equals 34.0 degrees. In part D, again, name the sides. Now, the side 3.8 centimetres is next to the angle theta and next to the right angle, so it's the adjacent side. The side 9.5 centimetres is opposite the angle theta, so it's the opposite side. Now we have opposite and adjacent, so that's tangent. We know the tangent of an angle is the opposite over the adjacent, so tangent of theta is 9.5 over 3.8. So theta is the inverse tangent of 9.5 over 3.8, which we can find on the calculator as 68.1985 degrees. So rounding it off, our answer is theta equals 68.2 degrees. In part E, we're given a triangle again, and we name the sides. The side 11.7 is the longest side, so that's the hypotenuse, and 9.3 centimetres is next to the angle theta, so that's the adjacent side. So we have the adjacent and the hypotenuse, and we know the cosine of an angle is adjacent over hypotenuse. So the cosine of theta is 9.3 over 11.7, or theta equals the inverse cosine of 9.3 over 11.7. So theta is 37.3568 degrees. Rounding that off, theta is equal to 37.4 degrees. Now, in question 3, we're given 2 points, A, which is the point 24, and B, which is the point 87, and we have to find the angle that the line AB makes with the horizontal, giving the answer to one decimal place. Now, to solve this, it's always helpful to draw a diagram, and we can mark in the points A and B and draw the line AB. Then we can draw a triangle under the line. Now, we can see that the base of the triangle is 6, and that is the adjacent side. The height of the triangle is 3, and that's the opposite side. And we know the tangent of an angle is the opposite over the adjacent. So the tangent of theta is equal to 3 over 6. So theta is the inverse tangent of 3 over 6, which we can write as the inverse tangent of 0.5. So, typing in the calculator shift tan 0.5, we get theta is equal to 26.565 degrees, or rounding it off, theta equals 26.6 degrees. In question 4, we're given a triangle ABC has sides AB equal to 7.6 centimetres, AC equal to 7.6 centimetres, and BC equals 4.8 centimetres. We are asked to calculate the angle BAC, giving the answer to one decimal place. Now, to solve this, it's always helpful to draw a diagram. And the first thing we notice is the triangle is isosceles. So, if we draw a perpendicular from A to the side BC, meeting it at D, this will bisect the angle AB. So the length BD is equal to 2.4 centimetres. And we can look at the triangle ABD. Let the angle BAD be theta, and we need to name the sides of this triangle. Now, the side 7.6 centimetres is the hypotenuse of the triangle. It's the longest side opposite the right angle. And the side 2.4 centimetres is opposite to the angle theta. It's right across the triangle from the angle theta, and so it's called the opposite side. And we know that the sine of an angle is the opposite over the hypotenuse. So sine of theta is 2.4 over 7.6, which means that theta is the inverse sine of 2.4 divided by 7.6. So on our calculator we type in shift sine in brackets 2.4 divided by 7.6 equals, and we get theta is equal to 18.4085 degrees. But we don't want theta, we want the angle BAC, which is twice theta, 2 theta. And so the angle BAC is twice 18.4085, and that's 36.817. So rounding it off, the angle BAC is 36.8 degrees. Now in question 5, we're told a man walks 3.8 kilometres on a bearing of 37 degrees, and then walks 2.3 kilometres on a bearing of 134 degrees. In the first part, we have to find out how far east he is from his starting point. Well, we definitely need a diagram for this, so let's draw a north, draw the first stage of his journey, and then draw the second stage of his journey. Now we can draw a triangle underneath each of those stages. In the diagram, we see that the total distance east he travels is the length AD plus the length EC. Now to work out the length AD, we look at the triangle BAD. And the first thing to do is name the sides. Now, the side 3.8 kilometres is the longest side, so it's the hypotenuse. The side AD is next to the angle, so that's the adjacent side. So we've got the adjacent and the hypotenuse, and we know the cosine of the angle is the adjacent over the hypotenuse. So cosine of 53 is AD over 3.8. If we multiply both sides by 3.8, we get 3.8 times the cosine of 53 is equal to AD. And if we type that into the calculator, we get AD is equal to 2.2868. Now we also want to work out the length EC. So we look at the triangle BEC. Now, in the triangle we have the angle EBC is equal to 180 minus 134, which is 46 degrees. And in the triangle BEC, the angles add up to 180, so the angle BCE must be equal to 44 degrees. Now we can work out the length EC. First of all, name the sides. 2.3 kilometres is the longest side opposite the right angle, so it's the hypotenuse. And we want to find the length EC, which is the side next to the angle 44, so that's the adjacent. So we have the cosine of the angle is the adjacent over the hypotenuse, which means the cosine of 44 degrees is equal to EC over 2.3. Now we multiply both sides by 2.3 to get 2.3 times the cosine of 44 is equal to EC. If we type that into the calculator, we find EC is equal to 1.6544. So the total distance east he travels, AD plus EC, is equal to 2.2868 plus 1.6544, which is equal to 3.9412. But we only want this to one decimal place, and so the distance east is 3.9 kilometres. Now, we want to find out how far north he has walked from his starting point. So the distance north that he ends up will be the length BD minus the length BE. So, to start with, we need to look at the triangle ABD. Now we want to find the length BD, and that's the opposite side. We already know the hypotenuse, and so we're using sine of the angle is opposite over hypotenuse, which means the sine of 53 degrees is equal to dB over 3.8, or 3.8 times the sine of 53 equals dB. And if we type that into the calculator, we get dB equals 3.0348. In the triangle BEC, the side BE is the opposite side, and we already know the hypotenuse, so again we use sine of the angle is opposite over hypotenuse. So the sine of 44 equals BE over 2.3, or multiplying by 2.3 we get 2.3 times sine 44 equals BE. So BE is 1.7092. The distance north is BD minus BE, which is 3.0348 minus 1.7092, which is equal to 1.3256. And if we want that to one decimal place, the distance north is equal to 1.3 kilometers. In part 3, we're asked to find the distance and bearing that he needs to make to get back. So we need to consider the triangle ACF. Now we know AF is 3.941 kilometers, and we know CF is 1.326 kilometers. And using Pythagoras' theorem in triangle ACF, we have AC squared is equal to AF squared plus FC squared, which means AC is equal to the square root of 3.941 squared plus 1.326 squared. Now that gives us AC is equal to 4.15809, which rounds off to AC is equal to 4.2 kilometers. Now if we call the angle ACF phi, then we can name the sides. The side AF is opposite the angle phi, and so that's the opposite side. The side FC is next to the angle phi, so that's the adjacent side. And we have the tangent of an angle is the opposite over the adjacent. So tangent of phi is 3.941 divided by 1.326, or phi is equal to the inverse tangent of 3.941 divided by 1.326. If we type that into a calculator, we find phi is equal to 71.40 degrees, but that's not the bearing. The bearing is the angle measured from the north clockwise round to the angle. So the bearing is 180 degrees plus 71.4 degrees, which means the bearing is 251.4 degrees. And that means to get back, he has to walk a distance of 4.2 kilometers on a bearing of 251.4 degrees.